Hey everybody, this is Larry, this is me going with Q3 of the Bi-Weekly Contest 109. Visit array positions to maximize score. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So, this one I thought was the trickiest one of the contest. Definitely, I feel like a brief scan of my Discord, and of course the contest is still going on. People seem to have gotten Q3 just like more mistakes. I mean, not that it's it's still a medium, it's fine, it's doable, but people have gotten more mistakes. I think there's two ways of doing it. The same way with dynamic programming. The tricky thing is that first is that n is 10 to the fifth, right? So the naive dynamic programming, the way that they define it, like if you're really naive about it, you can do something that's n squared, right? You have the basically longest path in a DAG and array the DAG with, or kind of, right? Yeah, and that's basically the way you would do it. But of course, n squared is going to be too slow because n is 10 to the fifth. There are two ways to do it. I actually did it a different way during the contest, and then and then I upsolved it afterwards. But basically this is my dynamic, my memorization solution. And basically we start out, we're forced to take nums of 0. So here we get the parity for it, and we get the score from it, and we start at index 1 afterwards. And then basically the idea behind every number is, do we tick or do we not tick, right? And then you ask yourself, what states do things add at if you take the number and you don't take the number? So okay, if the parity is the same, then it's if the parity is the same as the last. So okay, so index, let me actually redefine this for a second. So index is from 0 to n, that's just the index that you're currently looking at. And parity is you go to odd even of the last number taken, right? And that's basically the idea. And I actually misread this a little bit during the contest. During the contest, I thought it's odd even of the index taken, so I kind of wasted a little bit of time there. But I think I just did it bottoms up a little bit confusingly. But yeah, but basically you got to do two things, right? So if the parity is the same, then you always tick. I mean, you could, yeah, if the parity is the same, you always tick. There's really no yeah, I mean, you could also not tick, but basically if you want to split this out, then the tick not tick would be, this is the tick, and then the not tick would be the same thing. And I guess in theory, if this number could be negative, then maybe you don't always want to tick. But you look at this, that's how I kind of got into mind, is that this is tick, not tick, right? And then basically if the parity is not the same, if the parity is not the same, then we still do the same thing. We just have a different state. So this is tick and this is not tick, because the parity is and you can kind of see after a little bit that these are very similar, right? So we tick, then we have a new parity, so we make sure that you call it that way. But you also get the score, but you have to subtract it from x. Otherwise, you don't tick, and then you just keep the same parity as the last number. So that's basically the idea. This is memorization. So the index goes from 0 to n, parity goes from 0 to 1 inclusive. So the total time it's going to be equal to what is it equal to? Number of inputs times time per input, right? And number of inputs, of course, is going to be O of 2 times n, which is O of n. And then each input takes O of 1, time and space. So this is going to be linear time and space, right? And linear space. So yeah, that's all I have for this one. If you want to take a peek in my excuse me. Oh, geez. You want to take? I actually wrote it twice because I was a little bit worried. What the? Yeah, this is my bottoms up. It's the same idea, obviously, but yeah. And one thing that's cool about this is that you can actually reduce this to constant space, because if you kind of look at this, you can do the space optimization, and you notice that best of I only looks at best of I minus one, so you can get constant space that way. I'll leave it up to you to do it, but yeah. That's all I have for this one. Let me know what you think, and you can watch me solve it live in the contest now. Let's see. Positive integer x. We can move anything to the right. What is x? Oh, you're given x. And this is an awkward one. I should know this, but oh, nums of I and nums of j, not I and j. Okay, I misread that one. Okay. Okay, I misread that one. Okay, okay, I got it. You start at 0, okay. Ghost. Wait, is this right? Am I confused? Maybe I'm confused. What am I maxing? So it takes from the last 0, or we don't do. Wait, I'm slow. Okay, so basically if this is even, either take the last even number. Well, these should be negative infinity, actually, I think. Is this right? This feels a little awkward, though. If this is odd. Wait, if this feels a little off. Why am I so slow today? Okay, this is one. We don't do it, right? How do we not tick? I'm missing a decision. What am I doing? You always take this one's fine. If it's odd, then you do this, or you don't tick. Right. So this is this ticking. Okay, I think that's where my confusion was. Don't know how to code anymore. 13 and 20. Alright, let's go. That was sloppy. It's 2 pieces or something. But yeah, this one I probably should have done a little bit quicker. I'm gonna see if I'm gonna upsolve this just because for kind of want to do it upsolve. Just see if I could have gotten it much quicker, because I think I kind of confused how I did it. But what I could have done was maybe something like this. Right, so then if index is equal to n, we return 0. Otherwise, let's see what. Otherwise, what we do. So when odd, right? So yeah, if no, so if this is the same parity, then we can get. We can tick it, right? So same parity. We will take it. Ticking it will always be positive, I guess. Otherwise, if it's not, then we can either tick it or so this is if we tick it or not ticking it. So so we keep the same old parity. We have to take the number 0, so this is wrong the way that I did it. Well, maybe I wouldn't have gotten it right. How am I going to get this one wrong? 10. Oh, whoops. That's why. Okay. Well, that's one reason why anyway. Oh, and this is this plus nums. Oops. I'm just like all sorts of edge case. Yeah, so that would have been pretty quick. I mean, this may get... Yeah, so I should have done it that way. Then maybe I would... Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.